variables. So there's a small sandwich and there's a large sandwich. So I don't know. Let's just have x, because s will look too much like a 5 or something. So I'm just going to, x will be small sandwich, the number of small sandwiches. And y will be the number of large sandwiches. So again, I'm just picking variables for things that I don't know, but that I need to know to be able to answer the problem. So x will be the number of small sandwiches and y is the number of large. So now I need to put these into equations somehow, and that means I need to interpret the rest of the information given. Well, what is some other stuff that I know from the problem? I know how much bread or meat is needed for each type of sandwich, and I know how much bread and meat I have in total. So bread and meat are two different things. Maybe I can have an equation for each type of thing. I could have an equation that represents the amount of bread that I'm using, and I could have an equation that represents the amount of meat that I'm using. Sort of split these two concepts apart. There's bread and there's meat. So let's have a bread equation. And let's have a meat equation. I want to represent how much bread I'm using based on how many sandwiches I'm going to make. Yeah. Okay, so what do I know? I know that I have 1,300 inches of bread in total. And I know how much bread it takes for each sandwich. It takes 5 inches for a small, and it takes 7 inches for a large. So I can write down an equation like this because I know I have to use all of my bread. And it said 1,300 inches. Reading that right? 1,300 inches. I need to use all 1,300 inches, so I'm going to have this as my equation. 1,300 equals, then I need to represent the amount of bread per sandwich. Well, that's going to be 5 for the small and 7 for the large, so it's like 5x plus 7y is my first equation. This represents how much bread I'm using. Because again, this is the total amount of bread I have, which I have to use. And this represents how much bread I'm using for a small and how much bread I'm using for a large. This is my first equation. I can do basically the same thing for the meat equation. I have 550 ounces total of meat. And I know a small sandwich requires 2 ounces of meat. And a large sandwich requires 3 ounces of meat. And so this would be my second equation here. Okay. So I've successfully got 2 equations. I've used all the information that they gave us in the problem. So from here, all I would need to do now is just solve this system of equations. And now we have lots of methods for that. You could either do the elimination method, or you could do substitution, or you could make a matrix. It's sort of up to you now how you solve this. Cool. I don't know. Do you guys want to actually see me solve this, or do you guys think you could take it from here? I don't know. Would it be helpful for you guys to see me solve this?
Please solve it.
Yeah. Yeah, I'll go ahead and work through it just as extra practice. Word problems, the hardest part is always setting them up. And then once you set them up, you just have to know your math to be able to solve. So I'll rewrite the equations up here. Okay. So this is just a system of 2 equations. So how do I solve it? Again, maybe I would just do the elimination method here. So I want to cancel out one of the variables. I don't know, let's cancel the y variable and just see what happens. Yeah. So I have 7 and I have 3. I want those to be opposites. What would I need to multiply the equations by? Well, 3 doesn't go into 7 and 7 doesn't go into 3. So maybe I need to find some common multiple of the 2. So maybe 21 if I just multiply 3 and 7. So maybe I should multiply the first equation by 3 and the second equation by -7. So that I'll get 21 and -21. So we'll go ahead and do that. We'll do this first equation by 3 and the second equation by -7. Okay, so what's this times 3? 1,300 times 3, that sounds like 3,900. And then 5 times 3 is 15. 7 times 3 is 20. And then -7, oh boy, can I do this one? -7 times 550. So 3,500 plus 3,850 negative. You guys should double check if I did that right. Negative 3,850, negative 14x minus 21y. Multiply everything by negative 7. Okay. Assuming that I did that math correctly, these are our new equations. And I now just need to add them together. The 21s will cancel. This will give me x. 15 minus 14 is 1, so I just get x. And 3,900 minus 3,850 is 50. So x has to be 50. Right away, I know x is 50. I need to make 50 small sandwiches. Now to find y, I just have to plug this 50 back into one of my equations. So maybe I'll plug it into this 1,300 equals 5x plus 7y. Let's plug in 50 for x. That's 1,300 equals 5 times 50 is 250 plus 7y. So what's 1,300 minus 250? That's 12, not 12, sorry. 1050, 7y. Yeah, okay. 1050 equals 7y. And then so y is whatever that is divided by 7. 1050 divided by 7. And what is 1050 divided by 7? Yeah, arithmetic is hard even for us math majors. And when you're at the board, the problem doubles. And it's hard to remember how to do simple math in your head. 150 is the answer. So there we go. Our solution is I need 50 small sandwiches and 150 large sandwiches. That is my solution there. Okay. Cool. So any questions either about this problem or another? This is a very typical way to solve a system of equations, and it's a very typical word problem. You could expect to see something kind of like that on the exam, perhaps. Anyway, any questions? If you guys would like to see another problem, I could do another problem.
Could we maybe do a question about arbitrary parameters?
Yes. So let's see. Okay, so here's a good one that definitely has arbitrary parameters and will also let us practice solving a matrix. So maybe number 33 would be good to look at. Number 33. So this gives us a system of 2 equations with 4 variables. And so I can tell you, we can sort of work through this problem, and this will give us an opportunity to talk about arbitrary parameters. I was going to insist that I show you at least one matrix problem anyway, so this works out pretty well. So let me write the system up here on the board. We got 5x plus 15y plus 5z. Minus 15w equals negative 20. And that just happened. Oh my goodness. All right. That's never happened before. Oh. We're having all kinds of problems today, aren't we? Okay, cool. Everyone's still with me. Sorry for this minor technical mishap. Today is just not my day. Okay. And everything is okay. So hopefully that's back and visible. So where was I? I was writing this system of equations on the board. Now we have x plus 3y plus z and minus 3w equals 4. Okay. So here's our system. Let's solve this out. We're going to use matrix methods, and arbitrary parameters will come up in this situation. So let's go ahead and try to solve out the matrix. I'll write down the augmented matrix over here. I should have 2 rows, and I should have 4 columns to the left of the bar because I have 4 variables. So my first row is 5, 15, 5, negative 15, negative 20. And my second row will be 1, 3, 1, negative 3, 4. Okay. So let's try to solve this out. The first thing I want is, I want a leading 1 up in the left corner. There are 2 ways to get this, I think. One would be to just divide this row by 5, because I have a 5 here. 5 divided by 5 is 1. And the other option would be I could just swap the rows, because here I have a 1, so I could just move that 1 up here. It doesn't really matter which one you pick, and I think in this case I'm actually just going to divide the first row by 5, just because. Yeah. You could try to swap the rows again, it doesn't really matter. I think I'm going to divide the first row by 5 though. So we'll take 1 over 5 times row 1. So multiplying by 1 over 5 is the same thing as dividing by 5. So just divide everything in this first row by 5. What's my new matrix? 5 divided by 5 is 1. 15 divided by 5 is 3. 5 divided by 5 is 1. Negative 15 divided by 5 is negative 3. And negative 20 divided by 5 is negative 4. Okay. Maybe this isn't what I wanted. Well, anyway, let's see what happens here. Maybe actually this isn't going to give us arbitrary parameters, because what's going to happen, I want to now cancel this, make a 0. That's my goal. I want a 0 here. So I'm going to do basically negative 1 times the first row plus the second row, because I want to cancel this 1 and make it a 0. But notice if I do that, this will give me, okay, we'll salvage this here. I'm going to take negative row 1 plus row 2. What's going to happen? Well, 1 plus negative 1 is 0. 3 plus negative 3 is 0. 1 plus negative 1 is 0. Negative 3 plus, to become positive 3, that's also 0. And then 4 plus negative 4 is 4 plus 4, which is 8. So actually, I sort of lied to you. We won't have arbitrary parameters because this has no solution, because this row is zeros within an 8. So this last equation would tell me that 0 equals 8, which of course doesn't make any sense. Okay. So that's okay. This actually doesn't have arbitrary parameters, but let me just modify things slightly and then we will have arbitrary parameters. What if instead of negative 20, this was just 20? Let's get rid of the negative sign. What happens? Let's get rid of the negative 20 and make it a positive 20. So now my matrix is this. Okay, so let's suppose this was our problem. I'm going to try to solve this again. I'm going to do basically the same thing. I'm going to divide that first row by 5 again. 1, 3, 1, negative 3, positive 4. 1, 3, 1, negative 3, 4. So if I change it like that, then this is what happens when I divide the first row by 5. Notice these 2 rows are exactly the same. So when I try to get a 0 here by taking negative 1 times the first row and adding it, I'm going to make zeros everywhere in the second row now, because now I have a positive 4, which will become negative 4, and I'll get 0. So my new matrix will be this: 1, 3, 1, negative 3, 4, 0, 0, 0, 0, 0. Okay. Now, this is a reduced matrix. This is reduced. And I will tell you how to interpret the answer, and it's going to involve arbitrary parameters. So I'm going to rewrite this matrix up on the left. We have 1, 3, 1, negative 3, 4, 0, 0, 0, 0, 0. Let's see how this goes. So I know the matrix is reduced because this row has a leading 1 right here.